Have you ever looked up at the night sky and wondered about that constant silent companion, the moon? It's always the same face, a world of craters and ancient seas watching over us. But the moon is more than a pretty light. It's shaped our planet and life itself. Its gravity stirs our tides, perhaps even helping life emerge from the oceans. The moon stabilizes Earth's tilt, keeping our climate steady enough for life to thrive. Its surface is a time capsule, preserving the solar system's early history. As we prepare for new lunar missions, the moon's mysteries grow ever more compelling. Let's begin our journey to unravel its secrets. Have you ever gazed up at the night sky and wondered about the origins of that celestial pearl, the moon? For centuries, humanity has been captivated by its presence, crafting countless myths and legends to explain its existence. Theories abounded, each attempting to unravel the mystery of our lunar companion. But it wasn't until the age of space exploration with the daring Apollo missions that we began to piece together a more scientific understanding of the moon's dramatic origin. The leading idea, the one that best fits the evidence we've gathered, is known as the giant impact hypothesis. It's a story of cosmic proportions, involving cataclysmic collisions and the very building blocks of our solar system. To understand this, we need to journey back over 4 billion years ago, to a time when the Earth was still a young, molten world, swirling with potential. In this chaotic early solar system, a Mars-sized body, a protoplanet with its own unique destiny, existed. It was named Theia, a figure from Greek mythology, fitting for such a momentous role. Then, in a moment that would forever alter the course of our planet's history, Theia collided with the young Earth in a colossal impact. The force of the collision was unimaginable. It didn't just scratch the surface, the impact vaporized vast amounts of both worlds, sending them into a superheated, gaseous state. This cataclysmic event blasted an immense cloud of debris, a mixture of vaporized rock and molten material, high into orbit around the Earth. Over time, gravity began to work its magic, drawing this swirling debris together, forming a spectacular ring around the Earth, much like the rings of Saturn, but composed of the very stuff of planets. Slowly, relentlessly, this ring of debris coalesced, clumping together under its own gravity, gradually accreting into the celestial body we now know as the moon. And the evidence for this dramatic origin lies in the moon's very composition. Its makeup is remarkably similar to Earth's mantle, the layer beneath the crust. But significantly, the moon is lacking a large iron core, a feature that Earth possesses. This difference strongly supports the giant impact hypothesis, suggesting the moon formed primarily from the Earth's mantle and Theia's mantle rather than their cores. So, the moon, our constant companion in the night sky, was born from cosmic violence, a testament to the turbulent early days of our solar system. This cataclysmic birth forever linking its fate to ours, shaping our planet's tides, stabilizing its axial tilt, and influencing the very rhythm of life on Earth. The giant impact hypothesis also elegantly explains the moon's size, which is relatively large compared to its parent planet, a characteristic not commonly seen in other moon systems in our solar system. It explains its orbit, the specific distance and angle at which it circles our planet, a consequence of the initial impact and the subsequent formation process. And it even sheds light on why the moon is so geologically quiet today, lacking the active volcanoes and tectonic plates that characterize our dynamic Earth. The moon, in essence, is a relic of our planet's earliest days, a time capsule preserving the evidence of a cosmic collision that shaped the world we know. Its story is inextricably linked to our story, a shared history etched in the very fabric of our solar system. A story written in rock and dust, waiting to be further deciphered as we continue to explore the mysteries of our universe. To grasp the moon's significance, consider its scale. It's about a quarter the size of Earth. If Earth were a basketball, the moon would be a tennis ball. The moon orbits 384,400 kilometers away, far enough to fit all the other planets in between. Its size makes it unusually large for a planetary moon, almost a double planet system. The moon's gravity is just 1/6 of Earth's, letting astronauts bounce across its surface. This weak gravity means the moon can't hold an atmosphere. These numbers shape everything: tides, eclipses, and the challenge of reaching it. The moon is a world in its own right, defined by its distance and mass. It's our closest neighbor, yet still a vast frontier. Look up at the night sky. The moon, a constant companion, hangs there in the darkness. But have you ever stopped to wonder why we always see the same face of the moon? It's a question that has intrigued astronomers and stargazers for centuries. What cosmic forces are at play that keep one side of our lunar neighbor perpetually hidden from our view? The answer lies in a fascinating phenomenon known as tidal locking. It's a gravitational dance between Earth and its moon, a delicate balance that has shaped the very nature of their relationship. This locking isn't just a coincidence, it's a consequence of the immense gravitational forces exerted over billions of years. The moon rotates on its axis, much like Earth does. But here's the key: it completes one rotation in approximately the same amount of time it takes to orbit Earth. This synchronized movement is what creates the illusion that the moon isn't rotating at all, at least from our perspective on Earth. It's a cosmic ballet of rotation and revolution. More precisely, the moon's rotation and orbital period are both about 27.3 days. This near-perfect synchronicity means that as the moon travels around Earth, it presents only one face to us, while the other side remains perpetually out of sight. To understand how this came to be, we need to rewind billions of years to the early days of the solar system. Early on, the moon spun much faster than it does today, a whirling dervish in the cosmic void. But Earth's immense gravity began to exert its influence, creating tidal bulges on the moon's surface. These bulges weren't made of water like Earth's tides, but rather distortions in the moon's rocky material, raised by the Earth's gravitational pull. The gravitational interaction between Earth and these tidal bulges acted like a brake, gradually slowing the moon's once rapid rotation. This process, known as tidal braking, is a fundamental force in shaping the dynamics of planetary systems. Over millions and even billions of years, this relentless gravitational tug-of-war continued, the Earth slowly but surely wresting control of the moon's rotation. Eventually, this gravitational braking reached a point where the moon's rotation became synchronized with its orbit, locking one side permanently toward us. It's a gravitational embrace that has lasted for eons. Now it's important to dispel a common misconception. The far side of the moon isn't always dark. Just like Earth, the moon experiences day and night. The far side gets plenty of sunlight. As the moon rotates, all parts of its surface are exposed to the sun's rays. The key is that this side simply never faces Earth. It remains perpetually hidden from our direct view, a mysterious realm on the other side of our celestial neighbor. For centuries, the far side remained a complete enigma, a source of speculation and wonder. It wasn't until 1959 that humanity finally glimpsed this hidden world, thanks to the Soviet Luna 3 probe, which snapped the first grainy images of the lunar far side. These images were a revelation, opening a new chapter in our understanding of the moon. What those images revealed was a starkly different landscape compared to the near side. The far side is heavily cratered, a testament to its long history of bombardment by asteroids and meteoroids. It also lacks the dark Maria, the smooth, dark volcanic plains that dominate the near side. These Maria are vast basins filled with ancient lava flows, a feature largely absent from the far side. Scientists believe that the far side's thicker crust is the reason for this difference. This thicker crust made it more difficult for molten rock to reach the surface, preventing the formation of extensive volcanic plains. This asymmetry between the near and far sides provides a crucial clue to understanding the moon's violent birth, a cataclysmic event that shaped its very structure. While our moon's tidal locking might seem unique, it's actually a common phenomenon throughout the solar system and beyond. Many close-orbiting moons around other planets are also tidally locked to their host planets. However, the Earth-Moon relationship is still special. The size of our moon relative to Earth is unmatched in the solar system, making it a truly unique lunar system. So the next time you gaze up at the moon, remember that its unchanging face is more than just a familiar sight. It's a cosmic signature, a testament to the long and intertwined history of Earth and its celestial companion. It's a story written in gravity, time, and the enduring dance of the cosmos. The moon's gravity drives the tides, shaping coastlines and ecosystems. Twice daily, its pull creates bulges in our oceans, fostering rich intertidal zones. These zones may have helped life transition from sea to land. The moon also stabilizes Earth's tilt, keeping our seasons and climate relatively steady. Without it, Earth's axis could swing wildly, causing extreme, unpredictable climate shifts. This stability has been crucial for complex life to evolve. The moon is not just a companion, it's a guardian. Its presence has made Earth a cradle for life. Our very existence is tied to its silent influence. For millennia, the moon was a distant dream, until the space race. The Apollo program, born from Cold War rivalry, aimed to land humans on the moon. In 1969, Neil Armstrong and Buzz Aldrin became the first to set foot on its surface. That's one small step for man, one giant leap for mankind. They explored, collected samples, and left experiments, forever changing our view of the cosmos. 12 men walked the moon between 1969 and 1972, expanding our knowledge with each mission. The Apollo era proved what humanity can achieve with vision and determination. The moon became a symbol of possibility. Our footprints remain, waiting for the next explorers. After the incredible achievements of the Apollo program, a silence fell upon the lunar landscape. The last footprints faded, and the dreams of continuous lunar presence receded into the background. The moon, once a beacon of human ambition, waited patiently in the cosmic darkness. Decades passed, filled with other explorations and scientific endeavors, but the allure of our celestial neighbor never truly faded. Until now. A new chapter is about to be written in lunar exploration. NASA's Artemis program, a bold and ambitious undertaking, aims to not just revisit, but to truly return humans to the lunar surface, marking a significant leap forward in space exploration. This time, the vision extends beyond brief visits and flag planting. The goal is to stay, to establish a sustained and thriving presence on the moon. Artemis will etch its name in history by landing the first woman and person of color on the moon, breaking barriers and inspiring a new generation of explorers. This mission reflects the diversity of our world, bringing new perspectives and talents to the forefront of space exploration. The program is dedicated to building a sustainable presence, creating infrastructure and resources that will support long-term lunar habitation and research. The backbone of this ambitious endeavor is the powerful SLS rocket, a marvel of engineering designed to carry heavy payloads beyond Earth's orbit. Complementing the SLS is the Orion Crew Capsule, a state-of-the-art spacecraft built to transport astronauts safely to and from the moon. And orbiting the moon will be the Gateway Lunar Station, a vital hub for research, refueling, and support for lunar surface missions. The primary goal is to establish a permanent outpost near the lunar South Pole, a region of immense scientific interest and strategic importance. This location is particularly intriguing because water ice lies hidden in the perpetually shadowed craters, a resource that could revolutionize space exploration. This precious ice could be extracted and processed to provide breathable air, potable water, and even rocket fuel, making the moon a self-sustaining launch pad for future missions. This capability would be a game-changer, significantly reducing the cost and complexity of deep space exploration. Artemis will also serve as a proving ground, allowing us to test and refine new technologies, including innovative solutions like 3D printed habitats constructed from lunar regolith, and exploring the potential of using lunar lava tubes as natural shelters, protecting astronauts from radiation and extreme temperatures. The moon will become a crucial testing facility, a stepping stone for even more ambitious endeavors. It will provide invaluable experience and knowledge for future missions to Mars and beyond, pushing the boundaries of human exploration. Artemis is not just a nostalgic return to the moon, it's the crucial next step, a giant leap forward in humanity's ongoing journey outward into the cosmos. The new era of lunar exploration has begun, promising groundbreaking discoveries and a future where humanity has a permanent foothold beyond Earth. Long before science, the moon inspired myth and art. Its cycles gave us our first calendars. The word month comes from moon. Cultures saw rabbits, men, and gods in its face: Selene, Luna, Thoth. The moon was a symbol of change, mystery, and even madness. Think werewolves and lunacy. Its pull on our imagination is as strong as its pull on the tides. Artists and poets still find inspiration in its glow, from Van Gogh to Debussy. The moon connects us to our ancestors and to each other. Its story is woven into the fabric of human culture. Despite all we've learned, the moon still surprises us. Seismometers reveal it has moonquakes, some from Earth's gravity, others from its cooling core. The moon is slowly drifting away, about 3.8 centimeters per year, changing our tides and eclipses over time. Billions of years ago, it loomed much larger in our sky. Recent missions have found water ice in permanently shadowed craters, a vital resource for future explorers. The moon is a record of the solar system's history and a key to our future in space. Its stark beauty and silence continue to inspire. As we return, we seek new answers and new dreams. The moon remains our constant mysterious companion, our journey with it is far from over.